Okay. Let's see. We're construct a confidence interval of the population at the given level of confidence. And they tell us x is equal to 75, n is equal to 250, and 99% confidence. Well, first thing I'll do is I'll do this on a calculator. If you have a TA3, TA4, it's very, very straightforward. I remember where it's at. Stat and tests. And we want to go down to 1 prop z-int. I think it's next to A. There it is. So we want 1 prop z-int, and you press enter on it. It'll ask us for x, which we said was 75. N, which is 250. And it'll ask us for the C level. Since we want 99% confidence, we put in 0.99. It's always in decimal form. And I'm pressing enter after each one. And then enter on calculate. And that's our answer. So however many decimal places they're wanting. 225. And I'm not sure if they want 3, but that's what I'll do. And 0.375. And that would be your answer. Now, if you are doing it by hand, this is the formula that we're going to use. So we need to find p hat, for one thing. N we already know. Now, p hat is equal to x over n. So we're going to have 75 over 250. And 75 divided by 250. Yeah, 0.3. So now we have p hat, we have n, we need this z alpha divided by 2. Well, if we say 99% confidence, we take our curve here, we put 99% in the middle, and this all has to add up to 100%. So if 99% is in the middle, then 1% is in the tails, and it's split in the tails. So if you take 0.01 divided by 2 in your calculator, you get 0.005, like this. Again, the confidence they give you, put in the middle, and then it all has to add up to 100%. So 99% is in the middle, you put 1% in the tails, and you got 2 tails, so you split it in half. Now this right here is your z alpha divided by 2. And the table, if you're doing it by hand, is based upon the area to the left. Well, the area to the left is the 0.005 plus the 0.99. So the area to the left is equal to 0.995. Well, I need to look up the z-score in my table. So I'm looking here. I know this is kind of small, but you get the idea. This is table 5, the standard normal distribution table in the appendix. And I'm looking in the middle here, and I'm looking for 0.995. 0.995. 0.99. Here's a 0.9951 right here. That's 0.0001 off, and this one is also 0.001 off. So it's halfway in between this one and this one. Well, if I come over to the left, that says 2.5, and if I come up, this is 0.07 and 0.08. So we'd have 2.57. That's from the far left, or from this, and then the 0.07, and then it's halfway in between, so I'll put a 5 here. Again, it's halfway in between 2.57 and 2.58. Now that right there is our z alpha divided by 2. So at that point, I'm ready to plug in my formula. Like my lower bound is going to equal to p hat, which p hat we said was 0.3, minus z alpha divided by 2, which is 2.575, square root of p hat, which is 0.3, times 1 minus p hat, so 1 minus 0.3 divided by n. N was 250. And then the upper bound will be the same, but you just have a plus in there. Let's take a look at how to plug that in the calculator. So I got 0.3 minus 2.575 square root, so second x squared, 0.3 beginning parentheses 1 minus 0.3 close parentheses divided by 250. And to 3 decimal places. I'm surprised we got the same answer, 0.225. Now realize that sometimes your answer may be off. The calculator isn't based upon tables, so it doesn't have any kind of rounding error like this does. See, our table is based upon 2 decimal places, if not 3, if it's halfway in between. So your calculator, Excel, will always have a more accurate answer. And I won't go ahead and do it, but the upper bound is the same thing, but you have a plus in here.